Okay, so that concludes our sine examples that we saw in the previous videos. And really what I want you guys to do is, if you can, scan in this QR code right here and just take a look at, use it as a discovery of the comparison between sine and cosine. Now I can't animate it right now on because I'm just using a PDF, but it will take you exactly where this program called GeoGebra, and it's pretty slick. I would think that you might want to check it out and see how those interact with one another. But at any rate, the cosine wave is, here's the attributes of it before we start our example of graphing one. Okay, so almost identical as far as this business of the attributes. So we have two sine, I should say. And so we have amplitude of 1, okay? And the period is going to be the same. Remember, that's the distance where the graph starts to repeat itself. And going from here to here, exact same deal, 2 pi. There isn't any phase shift because we're not moving left to right any, and we're not moving up and down any for the vertical shift, but it works out the same way. You just start with a different parent graph, and basically it's the sine graph that is going to be shifted to the left 9 degrees or pi over 2. So we'll see. So the x-intercepts are going to be basically in this case where we're going to start off with the first positive one, which is going to be pi over 2, plus the distance in between each one, which is going to be pi n, where n is an integer, comma 0. And that will give us all of the x-intercepts from there on out. Okay, so we got pi right here and pi right here, etc., etc. And y-intercept is going to be 0, comma 1. Domain is negative infinity to a positive infinity. And the range is going to be just like sine, negative 1 to positive 1, including those. Okay, so in the video coming up next, we're going to take a look at this business of graphing cosine. All right, so something to keep in mind once more before we start diving into this is that sine graphs do this. Okay, so there's your sine graphs. And cosine graphs are going to start off like this. It looks like kind of like a horseshoe, I suppose. That. Okay. So you do the exact same thing. Yes, that's Winston losing his mind in the background, but anyhow. And so this is how we're going to go ahead and knock these things out. Okay. So amplitude, most of it works the same way, so it's not going to be anything different. So we got amplitude is the absolute value of a negative 2, which is 2. Okay. And so that means it's going to be bouncing back and forth in between a negative 2 and a positive 2. The period is going to look like this, and it works out the exact same way. So we'd have 2 pi divided by 1 divided by 3. The 1/3 right there is going to be the b value, and that's going to give us 6 pi. All right. So it looks like I'm going all the way out to 6 pi, and before we start shifting things around, this is what the sine graph or cosine graph is going to look like. Okay, so we want to start in, this is a negative right here, so we start upside down. Usually we would start up here, but it is negative, so we're going to start here at a negative 2, and we're going to end up at a negative 2 when we have pi over 6. We also have right in the middle here is going to be pi over 3, and then we have 3 pi over 2, and it looks like this guy right here. Okay, so essentially this is the graph before we apply anything to it. Okay, So now we got to tackle the phase shift because we know that that's going to be moving to the left or right based on information. Phase shift, I go over here and I realize that that is going to be going to the right, and the C divided by B here is going to be 2/3 pi over 1/3, which basically means is that it is going 2 pi to the right. Okay, so that means is that every single point is going to be hopping 2 pi to the right, which is a bit of a distance. So this guy is going here. This guy is going. Where am I at here? Hold on a second. I missed on that one. This guy is actually going here. Okay. And so what I do sometimes, just to keep my sanity when I'm counting these spaces, is like a 1, 2, 3, 4. So I'm just going to count 4. So 1, 2, 3, 4. So that's going to end up right there. Okay. So 1, 2, 3, 4, and that's going to end up right there. And likewise, 2, 3, 4, and 1, 2, 3, 4. So now I have this as my cosine graph, and it looks, there's a lot going on. So let me erase everything out, except for the cosine graph that we're dealing with right now. I'm going to mark the 2 pi to the right down here, and there's no vertical shift, so I want to get that out of the way. And let me clean up this graph here. Okay, so there we go, all cleaned up, and it appears like we are going to now be going after the x-intercepts. So x-intercept, first thing that we do is that we grab the first positive x-intercept, and I'm just going to go right to writing it down. So I got pi over 2 plus the distance that's in between these guys right here, which I believe is going to be, it was 3 pi, so we go 3 pi n, where n is an integer, comma, 0. Okay, and so we are almost there. We got the y-intercept, which I'm going to plug in 0 for x. So I got f of 0 equals a -2 cosine 1/3 times 0 minus 2 pi over 3, which is going to go ahead and give me, okay, so putting these pieces together here, I have a -2 pi over 3, which is going to be, and I'm just showing some steps here, pi over 3, and it's in tangentville, so it's going to be negative, and so I know that the cosine of pi over 3 is going to be 1/2, so, but it's in tangentville, so it's a -1/2, and so that's going to just give me a +1. So I'm going to adjust my graph a little bit here. As you can see, we're a little bit off. And I'm going to put it here at a +1. Boop. And now it goes through that a lot nicer. So x or y-intercept is going to be 0, +1. The domain is going to be from, I'm in the wrong spot here, -infinity to a +infinity, which is, again, it's not a word problem. And then finally the range, it's going to bounce it back and forth in between a -2 and a +2. Okay, so unless requested, that's going to be the only cosine graph that I do. But if you have a request for another example, hit me up on Remind, and I will be glad to cook one up for you. So thanks for watching, and see you in a few days.